Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, GeeksforGeeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, very good evening to all of you. Welcome to this amazing live mock DSA interview session where we are conducting interviews with our candidates. And let me first introduce myself. My name is Suniti and I'm a mentor here at Geeks for Geeks. So today we are going to conduct our interview with Yash. So let us welcome Yash with us. Hi Yash, how are you?
Yeah, hi Suniti. I'm doing good. How are you?
Yes, I'm also doing good. Thank you. So, welcome to this interview session. So, let us start it. So, first of all, can you please introduce yourself?
Yeah, sure. Hello everyone. I'm Yash Kashyap. I'm currently pursuing my BTech in computer science from Symbiosis Institute of Technology, Pune. If I talk about my college journey and some of my technical skills, I have been doing competitive programming and learning data structures right from my first semester when I got into the college. I went ahead to participate in a lot of competitive programming contests, and my team had also been the regional finals of ICPC Kanpur regions, and we secured a rank of 38 in that. Apart from that, I've also participated in contests like Google Code Jam, yeah, Google Code Jam, then Kickstart, yeah, another one which is hosted by Google. Then some of the Code Chef and Code Forces contests. And I have also been doing web development recently where I have built some projects. Apart from that, I have done two internships where the first one was in a research internship that was in Symbiosis Center for Medical Image Analysis. And then I went on to do a Hadoop development internship and Sysmat Soft Solutions. That was in this July itself. So yeah.
All right, that was really a very wonderful introduction. So, can you explain about your role while you were working as a Hadoop developer intern?
Sure. So, in the time period, my work was to actually integrate and develop a new scheduling algorithm under the Yarn framework, that is a framework in Hadoop. So, in that, I worked with in a team of 4 to 5 members where we developed an algorithm and we contributed it to the open source Hadoop repository. So, yeah.
All right, that's really an amazing work. And thanks for the introduction. So, before we proceed, I will quickly explain to you what we are going to do. So, a Google Doc link has been shared with you, right? So, I will be writing down the question in the Google Doc link, and then we will be discussing the approach and pseudocode. And then once when we are done on that part, we will move to the coding part. And for that, I will share the GFG's practice portals link with you. All right. And then you can code it there.
Yeah, that seems fair. Thank you.
Yeah. So can you go? Yeah. All right. So let us start with our first question, and that is, given an expression, find out if it resembles a correct set of parentheses. All right. So let me help you with the test case. Test case one that we have here is, all right. So if this is the test case, then your output for this should be true. Like as you can see, we are having this parenthesis, like the string that we have in this, we have these parentheses. All right. So as you can see, they form a valid pair. Like why valid pair? Because as you can see, all right, this is a brace, and then we have a closing brace here as well, and then for this as well we have a closing brace here, and then for these two are already together. So that's why we are saying that it is a valid parenthesis combination. All right. So let us say if another test case, I will tell you. So okay, let us say if this is another test case, then for this, I guess you can predict what will be the output for this. The output for this should be false. All right. So this is your question. Any queries or anything?
Oh, yes. So one thing I wanted to ask, are there any specific types of parentheses that are only used? Like in the first test case, I can see only three type of parentheses are used, which are the curly braces, the square ones, and the normal parentheses. So can I say
Yeah.
that
So
in the
only
max
these three kind
three
of
types?
parentheses will be used in the rest of the test cases as well.
Okay, great. So, hmm. So the first approach that comes to my mind will be using a hash maps and a stack. So what we can actually do is we can, so if I wanted to highlight, we can store the complements of each type of parentheses in a map. So for the so for this type for the square brackets, so for this type of parentheses, the square brackets, I can store a key value pair in my map where the key represents the closing one, the closing brackets, and the value represents the exact complement of that particular parentheses. So all the complements would look something like this. Uh, just a second. Yeah, something like this. And then for the last parentheses, it would be like this. So from using that, I can directly get to know about the complement of each of the parentheses. Or even if I don't wanted to do that, I can also use an if else statement, but that would require uh, almost 2 to 3 if else statements. But using maps, I can directly use them. So now the thing is, how do I use this information into my stack? So what I can do is, for every pair of opening brackets, for opening every opening parentheses,
Okay.
something that comes into mind is I can directly first check, is it present inside my map as a key. So for the first three parentheses, they are not present as a key in my map. All right. So what I'll do is, if I get any type of parentheses which is not in my map as a key, I'll push it into my stack. Um, I'll push it into my
What
stack.
is what is your
Okay.
key and value? Like what you are adding as a key and what you are adding as a value?
Yeah. So the key for every hash map would be the closing type of bracket. So for the square bracket, this would be my key, which is the closing bracket, and the value would be its corresponding opening version. So for the curly braces one, the left things would be my keys, and the right thing would be my values. Right. Uh,
All right.
okay. And
So
yeah, another
yeah.
question
So
that
I
I
mean,
had. Mhm.
okay.
Okay, another question that I that just came to my mind is this a valid type of pair? Can I say something like this? Uh, yeah, would this test case give me an answer true?
No, no, no. This is not a valid combination.
Okay, so this is not a valid combination,
Yeah.
right? Yeah, so my
No.
approach should be fine for this. Yeah. Any questions that you wanted to ask?
Yeah, like I was asking you about the key value pair that you are saying. So, like, let us say the key
Yeah,
you are using is as this closing bracket, right? So, when
yeah.
you will be inserting the opening bracket, so there can be multiple opening brackets, right? So, how are you going to keep the track, like if they are getting matched for every pair or not?
So yeah, that would be included in the logic that I'll be using inside my stack. So what I'll be doing is for every pair of opening brackets, I'll be pushing it into my stack. And how do I identify if it's an opening bracket? I can just check if it is present as a key in my map. If it is not present as a key in my map, then I know it's an opening type of bracket. It's not a closing bracket. So I just push it into my stack. So for this test case, let's say I push.
You are using hash map just to check if it is an opening bracket or a closing bracket.
Yeah, and I would also use to get the complement of those particular brackets ahead. So initially,
Okay.
for this test case, what I'll do is I'll push this into my stack, all right, because it's an opening type of bracket. Similarly, I'll also push this into my stack, and I'll push this into my stack. So these three symbols would be pushed into my stack, and later on, the next symbol that I get would be a closing bracket of square. All right. So as soon as I get a closing bracket of square, I'll check. I can check that using if it's present as a key. So yeah, it is present as a key. So I'll know that it's a closing bracket. So whenever a closing bracket comes, I'll just take the top element from my stack and I'll check if the top element from my stack, like let's say HD is my stack, if my stack, the top element of my stack is equal to the complement of the closing bracket. So the complement of the closing bracket can be received by this hash map. I can get that. So if it is equal to the complement of the closing bracket, I'll just pop it out from my stack. I'll just pop it out, and now when I pop it, I go to the next symbol. So this thing would be removed from my stack. All right, and now these two elements are present in my stack, and the next symbol that I would be receiving would be a closing parentheses. So again, for the closing parentheses, I'll do the same thing. I'll check uh, is the top element of my stack equal to the complement of the closing bracket. So yeah, it is equal to the complement of the closing bracket. So I'll also pop it from my stack, and I'll do the same thing for the curly braces, and I'll pop it as well from the stack. And if I arrive at a situation like after performing all the operations, if my stack is still not empty, or while popping from the stacks, I get a situation where the top element is not equal to the complement of the closing bracket, I can just return false, and I can say that uh, that does not resemble a correct set of parentheses.
All right. So, do you think that we really need map here because you use map just to check that if a complement
Uh,
is present? Or, yeah. So, I mean, you
right,
were
like I
just
said,
doing a simple matching, right?
right. So there was no necessity of using maps. Like I said, that would just save me around 2 to 3 lines of code, because I can directly check that using an if else statement. Like if the complement of that, because I already know the complements of each, since there are only three types of parentheses. But let's say if I had around 10 to 50 different type of parentheses, then it would be really difficult for me to know the complement of each and every parentheses. All right. So in that case, we would have used map, but since there are only three parentheses, I can ignore map and I can directly work with the FL statements.
All right. So, do you want to write down the pseudocode or are you comfortable with writing down the code direct?
I can do anything. I can just first quickly write down the pseudocode, and then we can move to the code. So what I do is I first create a ordered or unordered map. Doesn't matter. Let's go for ordered map to avoid any collisions. So the type would be of char comma char and complement. I'll name it as complement. And then what I can do is I can insert all the complements to this. So the complement for this would be equal to the exact opposite of that would be this. Sorry, uh, something like this. Okay, yeah. And similarly, I can do it for each and every kind of pair. So, mm, yeah. And I just change the type of parentheses. So, for this, it would be like so. Once I have all the complements, I can just create a stack of type character and let's name it st. And then for all the inputs, let's say the inputs are in the form of uh, array. Let's say if we have an array, so ARR. So what I can do is I can just do of size n, let's say, right? So I have an array of size n. So I can just quickly go through the array and I can insert if let's say I get an complement already. So if I get a closing symbol, so complement would be if I get a if ARR of I is equal to let's say the closing parentheses, or I can just copy paste this. So I stop pushing it to my stack, something like this. I'll just break out of my for loop, or else what I'll do is I'll just do st dot. I can push it to my stack. So I'll do st dot push, and I can push my ARR of I. So once I've pushed all of the stack elements, what I can do is I can run a for loop. Um, okay, so if this condition is true, I'll have to move to the remaining n by 2 elements since it's that. So I can run a for loop for int I equal to uh, and
I'll just interrupt
yeah.
you here. Like me, if you can just clarify me one thing. The statement that
Mhm.
you have written here is if array of I is any of the closing braces, then you are going to break it, right? Like you will break the loop.
Mhm.
Okay.
Yeah, right.
So, do you think this code will work fine in this case?
Okay, yeah. It would not. It would not. Right. So instead of that, what I can do is I'll not break it. I can just do continue instead of breaking. I'll just move to the next element. So yeah, if I encounter any of the closing brackets, I'll just move to the next element, and if it's a opening bracket, I'll just push it to my stack. So after that, what I can do is I can go through
Like
my
what you
array
are
one by
doing
two.
is, if it is a closing bracket, you are not pushing it inside the stack, right? And
Yeah,
only you are
right.
pushing it if it is an opening bracket.
If it's an opening bracket, right. So I'll push all the opening brackets to my stack, and then what I'll do is I'll start iterating from the back, but that would also cause me some trouble. Mm, Okay, so initially what I was thinking was I'll start iterating from the back, and if I get any closing parentheses, I'll check for the top element. But in that case, if I get an element like this, or something like this, then my stack would not work because
Yes.
this would cause me an issue. So, okay, so I can do that inside this for loop itself. I don't need to stop this. I'll not continue it. So if I get any of the closing brackets, I'll just check if it is present at the top of my stack. Right. Yeah.
Exactly.
Right.
Now you are on the right track.
Yeah. So what I can do is I can just do if it's a closing bracket, then I check if the stack or I'll just go for the false condition initially. If my st is empty already, or my st dot top element is not equal to the complement of arr of I, then uh, I'll just return false, right?
Okay.
But if that's not the case, then um, else what I can do is I'll just pop it out from my stack, st dot pop, and yeah, I think this should work. Also, another statement is if at the end my stack is not empty, if st dot empty, yeah. So if my stack dot empty is not correct, if it's not true, then also I'll have to return false, or else I'll just return true. So
All right, this seems fine. And can you help me with the time complexity and space complexity of the code?
yeah, sure. So the time complexity and the space complexity for both the for my program would be O of n, big O of n, because yeah, the time we are just uh, iterating over each and every element once. So that would go over all the n elements once, and to push it or pop it, it takes O of one time. So yeah, the time complexity would also be n, and the space complexity would also be n.
All right, but here you are using two linear data structures, right? Map and
Yeah,
stack.
right.
Okay, so you have used map here. So
Hmm.
maybe an ordered map will also work here because map will take an extra time complexity as well.
Yeah, but unordered map can also work, but just
But
to
yeah,
avoid
here we
collision, there
are.
is a
Yeah,
like
okay,
there's
tell
a
me.
concept of a collision in maps where
Yeah.
our map can actually blow up. So that could cause me an infinite amount of time for my solution to execute. So just to avoid that issue, I just used ordered map. So,
All right, but like here in that case, we have already inserted the key value pair. So
yeah,
like all the key values are different. So I guess collision is not going to occur here. And
yeah.
second of all, can you tell me the difference between map and an ordered map?
Yeah, sure. So maps, what happens is whenever we insert a key value pair, so all the entries of my ordered map is sorted by its keys. So in case of characters, it would be sorted by its ASCII value. So whosever ASCII value is smaller, it would be stored before in my map. So the major difference that occurs is whenever I'm searching for an element in my map, uh, it uses a binary search internally to find for the element, since it's not since it's ordered. So it takes an approximate time of login instead of O of one. But unordered map, it uses the concepts of hashing, so it we can actually access any element in the Armitage time complexity would be O of one for any element in unordered map for searching or inserting.
What is this concept of hashing? Like, what exactly do we do
Um,
there?
Right. So in hashing, it's basically uh, you don't put the order. Like in ordered maps, everything is ordered. Right. It's sorted. But in unordered map, we directly use the hash key. It's hash. It's converted encrypted into a hash value, and directly using the hash key, we can access the elements or like the value of any key. You don't need to do perform a binary search in that case.
Okay, so but map and unordered map, okay, ordered or
Yeah.
unordered, both implements hashing technique, right?
Yeah. So ordered also, to some extent, it uses hashing technique, but again, the same thing. It also ensures the order of the elements because it's already sorted. So it's uh, sorting all the elements in an ascending order. So that's uh, s- to some extent it might help us in some questions, but yeah, sometimes it's better to use unordered maps, like in this case, because it would save us some time.
All right, and if here instead of unordered map, if you would have used unordered set, would that have created any difference?
Unordered set.
Yeah.
Uh,
Do you think you can use
Another,
unordered set here as well?
but in another set I can't get key value pairs, right? So that if I want to find the complement, the whole point of creating a map was I wanted to find the complement of any particular element. But in sets, since it's a data structure where there is a single element present at every position, I won't be able to get an key value pair. If I wanted to find the complement of a particular symbol, that would be a bit hard
All
for me.
right.
Yeah.
Great. Okay, so I think we are sorted on this part. So let us move
Yeah,
to the coding section.
sure.
I have shared the link. Can you just open it and code it there? Like inside the doc itself. Yeah.
Okay. Yeah. Right. Yeah. This one, right? So yeah, C++ bool spare. So it's a string. So I'll try to use some of my code from here to save some time. I'll just
Yeah.
edit that. And we are checking for this. So this should also be returned. So now I'm creating an ordered map. An ordered map that should be the same. The parentheses can be changed. Over here, we need parentheses. This. Okay.
All right.
So I've created a stack, and instead of int n, I can what I can do is I can int n is equal to short size. That will give me the size of the string. So I know I can also put a base case if n is odd, then my answer would obviously be false. So if n is odd, then just return false to me. Or if it's even, then just continue with the this thing. Or I don't really need this, I guess. Okay, so if ARR of instead of ARR, it should be X. So if I okay, I'll also have to change this brackets. And if st.empty or st.top is not equal to complement, this should also be X. I just return false, else st.top top, or I just push it. And if there's, let me see if I'm missing something. Let's try to compile it once. Okay, so it's not, okay. It's not balanced because your output is not balanced. So it's returning me false somewhere. Hmm. Let's see why. Expected output. Expected output should be balanced. So if I do
I
true
think
here,
if stack dot empty, maybe you can add that line outside
over
the
here,
if condition that you have written.
um, outside the condition. All right.
Yeah.
That.
Inside the loop, but outside the if condition.
All right. So no, but in that case, if I put it over here, so again, in this case, it would fail, right? So if I have something like this, so when it's this is a valid pair, but once it has removed the second element from the stack, my stack would be empty. So before entering this element into my stack, it will check if my stack is empty or not, and it would return me false because my stack would be empty. as a third
Yeah,
index.
exactly. But then, you should do this push statement in the beginning, and then you can check if it is empty or not.
Okay, but if I'm pushing
And
something
also,
into my
yeah,
stack,
also
yeah.
one thing I would say that you are pushing all the elements inside the stack, right? I mean,
No, I'm not.
you are
I'm
pushing
not pushing.
closing
No,
brackets as well.
no, I'm not pushing the closing
Uh,
brackets, because if it's a closing bracket, then my condition would go into this if else statement, and in this if else statement, okay, yeah, right. So that was
yeah,
the issue.
there it should be an else.
So I should also continue from to the next loop if I'm popping it. I should not push it to my stack, and this was not an issue. So I can put the t dot empty condition over here, or and yeah, now I guess it should be fine. Let's see.
Correct the spelling of empty.
Uh, okay, sorry, my bad. There's an compilation error. I guess some parentheses error. Hmm. This starting bracket is here. This is here. For the for loop, it's here. So was it
Yeah,
an
all
error?
right. So tell me how will your code will execute when we are on the first element of the string itself? Like
So
it will give return true for if stack dot empty, right? Stack is empty right
yeah,
now. So
right.
yeah, and as our stack dot top is not matching to any of the complements, so it will try to do stack dot pop, but as stack is empty, so this pop
Hmm.
function can't be performed, right?
Will be give me and it'll give me a runtime error side. So okay, so what I can do is, if it's an
You can
closing brackets, only then I should check for stack.empty. I should not initially check it for stack.empty. So if it's in closing bracket, only then I'll check it for st.empty.
or maybe after the for loop you can write that if you will only push inside the stack if it is an closing, like if it is an
Yeah, right.
opening bracket, then you will push it inside, right?
Yeah,
So that
even that should work. So I don't think this should make an issue. This line, even
yeah,
if I
but
comment this line out, it would be fine. Right. Let's
yeah,
try this. Hmm. So let's try to submit this. It works. Okay, no, it did not. Some segmentation error again. So why is that a segmentation error this time? Yeah, so I'll have to check for the stack.empty, because it'll try to pop the element if
yes,
it's in closing bracket at the start. So if the stack is empty, I'll just return false. So now I'll try to submit this. Okay, this should work fine. Yeah. So this worked. Right.
all right.
Hmm.
So okay, so now we are clear for this,
Yeah.
and also like you have used an unordered map here, so because you
Right.
wanted to avoid that if else ladder, that could
Hmm.
have.
Yeah.
Uh, so instead of using map for avoiding the if else ladder, you could have used switch statement, right? So it would have saved you some space. So you can try that
Mm,
as well, all right, to
yeah.
avoid
Right.
using map. Okay, you
Yeah.
can check that
Thank you for
whatever the closing bracket you are getting on the top of the stack, so you can match
Hmm.
it if you know the switch, like you can make the switch for the characters, and then you can check
Yeah.
that if top of the element are getting matched or not, right?
Yeah.
So switch
Understood. Yeah.
statement
Right.
also help you. So
Yeah.
okay, that was about this question. You did great. Let us
Hmm.
now move to our next question. All right,
Okay.
and that is find out the length of the longest subarray with some key. Okay.
Hmm.
So I will give you a test case. Let us say the test case that first test case that we have is all right. So array that is given to you is 10, 5, 2, 7, 1, 9, and the sum that you have to find is 15, right? So you need to find out the longest subarray which will give you the sum 15, right? So here, as you can see, the output will be, you need to print the length of the longest substring. All right. So here the length of the longest substring will be 4, because the subarray is going to be 5 to 7. See, as you can see here, 10 and
Right.
5 will also give you 15, right?
Yeah.
Yeah, so
Right.
that is, but this 5 to 7 one, this is the longest subarray, which is going to give you some 15. So that is our motive here, to find out the length of the longest subarray, which will give you the sum k. Okay.
Right. Yeah.
Yeah.
Okay. Just a small clarification. My subarray should always be continuous, right?
Yeah, sub array is a continuous part of an array.
Okay. Right.
Subsequences are not continuous.
Yeah. Okay. So what I can think of is I can maybe use a two-pointer approach in this. Let me just verify this. So what I'm thinking is if we try to keep some pointers, so let's start both the pointers from the first element itself, and until I get the sum as 15 or greater than 15, I'll keep on pushing my right pointer. Let's say we have two pointers L and R. So I'll initially both will point to the first element, and if the sum bit we and we'll store the sum of all the elements between L and R in a variable, sum variable. So until this value of sum is less than 15, what we can do is less than or yeah less than 15, what we can do is we can increment the right pointer to the right, and as soon as we get a sum equal to 15, what we can do is we can have another answer variable in which we'll be storing the longest sum of the longest subarray. We'll update that as soon as we get a length of 15, a sum of 15. And if we get a sum greater than 15, we can just keep on moving the left pointer to the right until we get the sum as 15 or less than 15. So again, if it's 15, we'll update the answer variable. But if it is less than 15, we'll keep on moving to the right side. And we'll keep on doing that until the right pointer cannot move, until the right pointer is at the last index. So yeah, I guess that
Uh,
should work.
Array contains negative numbers as well.
Okay, so it contains negative numbers as well. All right.
Yes.
Uh, hmm.
So I guess in that case, the approach that you just said, so I
No,
think
yeah,
that won't
it
work.
would it would not work. Yeah, right.
Yeah.
Because in case of positive numbers, my sum is always is increasing as I move ahead. But in negative
Yes.
numbers, that would not be the case.
Exactly.
So I'll have to think of something else. Okay, so again, the first approach, the brute force approach that we can do is we can iterate over all the subarrays, all the possible subarrays that is possible with this particular array, and we can check for the sum. If it is 15, then we can just pick out the longest subarray out of those subarrays. So that would be a very naive and brute force approach. But the time complexity that would be very inefficient, and the time complexity for that would be big O of n square, because that would be the time taken for to find out all the subarrays.
Yes.
Now, if I want to do a better, if I want to make it efficient, what I can do is I can have maybe have a sum variable with zero, with in which I'll be storing a sum and my answer variable, which is zero. And mm, okay, and for all the elements, what I can do is I can add it to my sum, but hmm,
All right.
hmm.
Are you feeling stuck?
I'm thinking I have an approach, but I'm just verifying if it would work. So what I can think of is I can like have some sort of an hash table where hash map where I can just store the sum and like the index tuples. So from 0 to n minus
Yes.
1, I'll go through each and every element, and I'll just like accumulate all the sums, like all the ARR of I to my sum variable. And if the sum variable is equal to k, then again I update my answer, uh, like my answer variable with +1. But if the sum is okay, so that would be an issue. Hmm.
Like the intuition that you have, we are going to use
Hmm.
hash map. That is correct. Like
Hmm.
you can solve this question with the help
Right.
of hash map. Now you just need to, figure out how hash map can help you here.
Hmm. Right. So
Like what exactly are you looking for? I mean, for finding out the longest subarray, like which things will help you? Index values, right?
yeah, so all the indexes value and the sum maximum, the
Some
sum that
till
I
that
can,
index value.
yeah, some till that index value I can use that. Okay,
Some-
so hmm. Right. So maybe we can use a prefix sum in this, where we can store all the prefix sums into my hash map. So for 10, I'll store all the, like the sum of all the numbers till 10 into my hash map. For 5, I can store all the, like the sum of all the numbers till 5 in my hash map. So I'll store 15 with the index, obviously, that 5, that I is equal to 1 is the closing index. Then for 2 again, I can store all the sum over here. All right. Till 7, I'll store 7 plus 2 plus 5 plus 10, which is, I guess, 24 with the index. And for 1 and for 9, 2. And then what I can do is, since I know that, let's say if I want to check for this subarray, so what I can do is I can check if the hash map till, or the sum till the last element minus k is already present in my map or not. So that would be maybe this value. So if this value is present in my map, that means there exists a subarray which will uh, determine that, yeah, I can have a subarray with this particular sum. And out of all those subarrays, I can just get the highest answer, and I'll keep on updating the length of the subarray to my answer. So I guess that should work. So mm, if I have something like this, I'll store these key value pairs in my maps. So my key would be, let's say, sum. Like the initial value would be my sum. So I'll store 10 into my hash map. That 10 is present with the value I. Um, 10 is present, or I can just do 1 because 10 is present once. Yeah. How would I search for some continuous values?
Can you hear me? Like,
Yeah, now I can. Initially, I was unable to.
all right,
Hello?
Yash. Like,
Yeah.
okay.
Hmm.
So, see, what you can do is maybe you can keep on adding all the elements that you have. Okay.
Hmm.
Like inside the sum variable, say you can create any variable sum and you can keep on
Hmm.
adding all the array elements inside that sum, right? And
Yeah.
then maybe you can check that if you can create a hash map where you will update the index value according to the sum. Like what will be the key value pair? Key will be the sum, all right,
Some.
and
Yeah.
value will
Right.
be the index. Value will be
Yeah.
the index of that sum.
Right.
Okay. Yeah. So then you can check inside your map like for the longest subarray because you will have
Right.
indexes of all the sum that you have.
Accumulated till now, till that particular
Yeah.
time. Yeah.
Exactly. So
Right.
you will have all the indexes. So that can help you. So
Yeah.
maybe you can try that approach.
Yeah. Yeah. Right. So should I write the pseudocode for that?
Yeah, first of all, let
Uh,
us clear out the pseudocode and then.
yeah. So I can have the initial sum as 0, and then what I can do is, I'll create another unordered hash map, unordered map of end comment where my keys would be the sum. Let's give the name as MP. And now I'll also have my answer variable which will be storing the maximum length, or the, I can keep it as the subarray length as 0 initially. And I'll iterate through my array I less than n I plus plus. Right. I'll go through my array and I'll first add it to my sum, the particular number. So sum plus equal to error of I. And after adding the sum to my adding the element to the sum variable, I can check if there's So if uh, there exists a value with or there exists an index. Okay, but in that case, how would I know that my sum minus k? So I'm trying to
Yeah.
find for sum minus k if that is present in my
Right.
map. If
Yes.
MP of sum minus k, how do I know if it is present or not? Because by default the values would be storing zero. That so it might. Okay,
So
we can
you can
use
use
maybe a one
MP
based
dot,
indexing. Sorry.
like you just want to check that if some minus k is present inside the map or not, right?
Yeah, yeah.
So why not use MP of some minus k is not is equal to MP dot n?
Is not equal to MP dot end.
Yeah.
Um, right. I can do that, or I can also maybe use one based indexing over here. And if MP of sum minus k is giving me zero, that means it is not storing any value because by default all the values inside this map would be zero. So if
Zero, yeah.
MP of sum minus k is equal to zero, then I know that that particular value is not present in my map.
All right, Yash, can you
So
just scroll up a little bit because your code is getting hidden by that banner?
okay, yeah, yeah.
Yeah.
Is
Okay.
it fine now?
Yeah, yeah.
Yeah, great. So what I'll do is I'll just check if MP of sum minus k is equal to zero. I'll just not do anything. I'll move to the next index, but I'll also have to insert this p value pair.
Yeah, you'll need to update
So
it.
yeah, so I'll do MP of sum is equal
So,
to I plus one because here
okay,
I'm
one based
using
indexing.
the index. Yeah, one based indexing. I'll do I plus one and I'll just continue to the next element.
Okay.
Continue searching for the next element and I'll not update my subarray length. But if let's say it is present in my map, so now I know that there is a subarray which has the sum k, so I can just initially update my answer. So my subarray length can be updated to MP of uh, sum minus k. So that would give me the index. So let's say if my index is one, which is storing it. So I'll also have to put I plus one minus this. That's what I guess give me the length because if I'm at the second index and I get the sum as this, so my answer would be one. So yeah, I plus one
Yeah,
minus MP of sum minus k should give me the subarray length. And once I
that's
have the subarray length, I can just add that key value pair to my uh, this map. So I'll do MP of sum is equal to I plus one. And yeah, once I'm done with all of this, I can just return the subarray length, whatever I have.
all right. Like we need to have the maximum subarray length. So do you think that you should be comparing
Okay,
the subarray length? Yeah, you
right, right,
should be
right.
writing. Yes.
So it should be. I should not directly update it. I should take the
Yes.
maximum of subarray length. So with this. So yeah,
Yeah. Great.
should be yeah.
All right. So
So
now
go.
this code looks good. So can you tell me the time complexity and space complexity of the code?
Right. So the time complexity, we talk about unordered maps since inserting and searching for elements take amortized time of one. The time complexity should be it should be linear. It should be big O of n, and the space complexity should also be O of n because we are not having any extra array in this. We are just using single variables. So yeah, both of them would be n.
Great. So, okay, uh, everything seems fine here. So now we can move to the coding part.
Sure.
So, all right, can you please open that link?
Sure. Okay. So here I have the array n and k C++. Okay. So initially, as I did, I'll just initialize the sum variable to 0 and the my answer variable with also 0, and I'll have an unordered map of type int comma int. Let's give it as MP, and I'll just iterate through all the elements. So I is equal to 0, I less than n, I plus plus. So yeah, once I'm inside the for loop, I'll just add it add the sum to my p of I. I'll add it to the sum variable. I'll just check for the condition if the complement is present. So MP of something like sum minus k is equal to 0. Then I'll update the sum to this. So update MP of sum equal to I plus 1. Yeah, MP of sum is equal to I plus 1. Yeah, right. And now what I can do is I can just move ahead. Right, I can move ahead. But I guess there can be issue with this code because what if in this case every time the value with the sum is getting updated with the farthest index, right?
Yeah.
uh, but let's say if I have sum variable, I have the value of this subarray as 10 and also this subarray as 10. All right, so the index that would be getting stored in my map would be of this subarray, right?
Exactly. So actually, there is one condition that you have
So,
missed.
right. So there
So
should be another condition which will always store the minimum length of minimum index with every sum.
no,
That
like
will give me.
you
Mhm.
should, yeah, like you can do that as well. But just to save some space and save some statements, what you can do
Mhm.
is like you are adding all the array elements inside the sum, right?
Yeah.
So if that sum is getting equivalent to k, then what you can do is you can directly make your subarray is equal to I plus 1.
Uh,
Did you
yeah, but
get
that
my
would
point?
only right. But that won't that check only for the condition if my subarray starting from the first index is equal to k? That would
Yeah,
ignore
exactly.
the
So
middle subarrays, right?
that's the only condition that we are missing, right? I mean, starting from the beginning, because all the middle subarrays that are being taken care by some minus k when you are checking inside the map. So that
So let's say
is being taken
if I
care, right?
have a subarray like this, where I have 10 as my first element,
Yeah.
2 as my second element. So over here, my sum is 12, and let's say I have another 4. So the sum of this subarray is 4, and then minus 2, 2, yeah,
14.
something like this. So 7 and 8, and let's say the required sum is 16 or 15. Let it be 15. Okay, is 15. So what would happen is
Okay.
I'll update 10 to my this map. I'll update 12 to my map. I'll update 14. Sorry, 16 to my map. All right, and the value corresponding to 16 would be storing the index of this particular element, which will be 2. But
Yes.
if I move ahead and if over here also for this subarray 2, the sum would be the same. It would be 16. So my sum, the index value corresponding to my sum would actually get updated to this particular index, right?
So yes.
So that could give me an issue, right? Because whenever I'm checking for this sum, I'll do what the 15 plus 16, that is 31. So I'll check for 31 minus 15 if 31 minus 15 is present in my uh, map or not, right? Because the sum for this would be 15 that I want. I want this as my subarray.
Yeah. So like whenever you are starting from the beginning, I don't think there is any subarray which is giving the sum 15 except for 7 and 8.
Uh, no, but I'll check for 16, right? Because over here the sum of all the arrays would be 31, and I want
Okay.
to get this particular subarray as my answer
Yeah.
with sum 15. So what I'll do is I'll check for 31 minus 15 if that is present in my array or not, right? In
Yeah.
my
So
map.
31 minus 15 will give you 16, right?
16, yeah, it will give me 16. But there
Yeah.
are two subarrays currently, which is giving me the subarray as 16. So this one and
And
also this one.
so, like, what I will be storing the maximum index that, like, you can do the I minus MP of sum minus K that you have already done there.
Yeah.
So I
So
think it will get
my MP of sum would be getting updated to I plus 1. So my ith would be this. But
MP
what
at
if I,
16 will be MP at 16 will be 5, right?
yeah, it will
Yeah,
be
MP
5.
at 16 will be 5. Yeah.
Right.
So you
Uh,
can do, and currently, like, say, let us say currently you are at 8th, means you are at
hmm,
7th position, right? So you can
yeah.
do 7 minus 5. So that will give you the length
7 minus 5.
5. Yeah.
Yeah, so that would give me the
I
length 2,
minus,
which would be this
yeah,
subarray, right? But
exactly. So you will
yeah,
get
but
the required
the
answer.
no, but I wanted the longest subarray, and the longest subarray is
Long,
not this. The longest subarray would be this with the sum 15, right?
right. So if we are checking for, we just
So I'll
check.
have to make sure that the map variable is always storing the element, the earliest element, the index of the earliest element with that particular sum to
Okay.
get the maximum length. So over here, what I can do is, okay, so let's just try this approach that we discussed, and let's see if it fails. I'll just make the necessary changes.
All
So,
right. Okay. So yeah, I have just
uh,
shared code.
yeah, sure. So MP of sum files, let's continue, and then I'll just update the summary after this. So my answer would be, it was I plus 1 minus, yeah, maximum of answer comma, max of answer comma, I plus 1 minus my MP of sum minus K. This would be my answer, and then I'll just update it to my uh, answer with some variable. So I'll do MP of sum equal to I plus 1, something like this. Okay. And I'll just return the longest array,
Okay.
but I don't think this should work. Let's see.
And like,
Um,
you can add one more condition that if
mhm.
the current sum is coming out to be as equal to k, then you can directly return I
Yeah.
plus 1.
Uh, hmm, but
That will always be
uh,
the longest subarray.
no, that would not be the longest array,
Yes.
right? Because let's say in this particular case
Because it
itself,
is starting
I,
from the beginning.
yeah. So let's
And
say
we are
over
just
here, I
checking
wanted
that.
the sum
Yeah.
as 16. For this particular case, I
Okay.
wanted the sum as 16. So as soon as I get to 4, my answer variable would get equal to 16, and my program would return 3 to it. That would be
No, like,
this.
don't return it, update the subarray length.
Okay, okay. Updating the subarray length. Yeah, that makes
Yeah,
sense.
don't return it.
Yeah, right. Then it should work fine. So if my sum is already equal to k,
Yeah.
then I can just put
I mean,
answer.
this could be one of our potential answers, right?
Yeah, right, right,
So,
definitely. Um, that would also be taken care by this one. No, it would not.
no, no,
Right.
no.
Instead of that, I could also put MP of 0 is equal to the initial index, something like that.
You don't need to keep the track of this max thing here. You can just simply update it, because I guess if the
Oh,
current index is giving you a value, then it will always
yeah,
be the
yeah, right,
max.
definitely, exactly. So as soon as I go ahead in my array, it will always get updated to the longest sub array.
I plus
So if my sum is
yeah,
equal to answer is equal to I plus 1. Yeah. Let's see if this
yeah.
works. Hmm. Okay. There was some compilation error with capital K, not small k. Right. Error expected output matches. Let's see if it passes all the test cases. Okay, no, it does not. I guess for the same reason, your code output is 4. So for 15. Yeah,
So
let me just update that, and I'll see if that works. So I'll always update this as, if if MP of sum
All
minus k
right.
is equal to
Can
0.
you tell me why you are checking if sum minus k is equal to 0? You can just check if sum is equal to 0, right? In line
Uh,
number 20, rather than checking if like you are adding the current index value, right, of MP sum, you are updating it, like what is the maximum index value that you are getting, right?
yeah.
So checking for sum minus k, you should just check for sum, like what is
Uh,
the sum, at what maximum index value you are getting a certain sum.
yeah, but if that sum would be 0, then
Yes.
it doesn't mean that I don't include that answer to my answer variable, because k can also be 0, right?
No, like you
So
should when you are updating inside the map, you are updating MP of sum is equal to I plus 1, right? So for
over
that,
here,
you should check if MP of sum is 0 or not. No, yeah. Rather than writing sum minus k, you should just write sum there. Rest
uh,
line number 20.
line number
Rest
20,
everything
right?
seems, yeah. Rest everything
So,
is fine. Yes.
so this thing, let's see.
Yeah, exactly.
Yeah, so if my MP of sum is 0,
And
still
also,
not
why
passing.
this continue? Like you can avoid this continue thing because
uh,
it will not update the answer.
okay, so if my MP of sum is 0, that if I don't have that particular sum, right?
Yeah.
So if I don't have that sum, I don't. Uh,
And if that sum is occurring right now, so you will need to add it inside the map.
yeah, so
So
I'll
this is what you're checking.
wait. Let's see. I don't think so. Because
Yeah,
over
I guess
here, I'm checking
that
if
there is
MP of
this
sum is
issue
equal
with.
to 0. Hmm. Yeah,
I guess then there's the issue with this find. You just use the find function that will work well, I guess. If MP dot
yeah,
find
so right.
sum is not, yeah. So because like as you said, by default every element is having this value of 0 inside the map. So
Yeah, right,
that
right.
might be
So
yeah.
that's the issue that's occurring basically. So if
Like you should be using if MP dot find sum is not is equal to MP dot end, rather than because
right,
yeah,
it would
it's a
move to the
pointer.
like it would point to the last element.
Yeah,
And
it's a pointer.
if
So
it's not equal to, if it's equal to n, then I don't have
equal
to.
to,
Right. So if it's equal to MP dot end,
and also I guess you can remove that continue statement.
uh, no, but in that case it would also, yeah. Let's see. Continue
And yeah,
statement.
you can remove that line number 26 as well because we are already adding it.
Yeah, we are
Remove that. We are
MP
doing
dot
that thing
find some.
already.
No, but we are only doing if it's equal to MP dot end. Yeah, we are submitting this. We are adding it. Otherwise, we are not. No.
And I guess you should add an else as well because in
Oh,
in the case if sum is already present, then in that case you will update your answer, right? Because sum is already there, so in that case you will be
yeah.
updating your answer as what you
Updating my
will,
answer,
yeah.
I'll not update every time. Right. So that's why
Yes,
I
you will
use
only
this
update if
information
that current sum is present.
is present. Right.
Yes.
No, it's still not open. The correct output is
Okay, so
0.
just a second. uh Maybe like okay.
I guess I'll need another.
No, I guess you don't need to write I plus 1. I mean, maybe you can do with just I by I plus 1 because now we have
Yeah, now we are
removed
not
that.
actually. Uh,
Yes, we are now not using it. So in this case, you will need I plus 1. Yeah,
in this one, I
here
won't.
you can do.
Right.
And also on in line number 26.
Line 26 as well. Right. So
Yes.
yeah. So I'll update. No, but that will still be the same. If I do I plus one over here, I'll have to do I plus one. I guess I found the issue that was there. What I was not doing is I can, instead of this else condition, I can check if my sum minus k is also not at the end. That means right now I'm only checking if my sum is present or not, but I'm forgetting about the
Exactly.
initial index, right? So what I can do
Rather
is I
than
can
keeping
do,
it inside an else, it should be inside an if clause only.
yeah. it can be f dot find sum minus k, and if it is not equal to mp dot end, that means it is present, and it's not present inside my this. So I can just update my answer variable, max
Hmm.
of answer, comma. Since I'm using one page indexing, I'll just do I minus mp of sum minus
So
k.
minus
Yeah, I guess this should work.
all right, and correct the spelling of
Yeah,
answer.
yeah. Sorry.
Okay.
Let's see. This works. I guess this should work. Yeah. No. It's a compilation error. Yeah, it should be capital K again. Yeah, it should work. Hmm. It's working.
All right.
Great.
So finally you solved it. So
Yeah.
great. So that was the two questions that we had in today's session. Now let us move to the feedback part. So before going ahead, how much would you rate yourself on the basis of this interview session?
Um, I would rate myself as a four because I was a little bit stuck in the last
Out
debugging
of
part
10.
where
Out of
out
out
of
of 10.
okay, okay, so out of 10 it would be 8 or 8.5. Yeah.
Yeah,
Yes.
fair. Actually, see, the
Yeah.
thing is that first question you did really well.
Yeah.
I think that there was some extra time that was being taken, but it's okay as at the last you were
Mm-hmm.
able to arrive at the approach without any help.
Okay.
So,
Yeah.
like, there was just normal discussions, and your
Hmm.
communication skills are really great. So, with the help
Yeah.
of that, you were able to arrive at the final conclusion, right? So, for the first
Yeah.
question, it's 10 out of 10. No issues there. And in the
Thank you.
second question, you did need some help, right? There were some hints
Yeah. Right.
required, and yeah, that is
Right.
there. But your logical part is very strong. Your
Hmm.
communication skills are very strong. And so you
Yeah.
were able to arrive at the final answer of this question as well, and you figured out it
Yeah.
yourself only. So
Yeah.
we can have 8.5 for this question. All right, because there's
Sure.
always a scope of
Yeah.
improvement. So, like, so
Definitely.
let's keep that gap. So 8.5 for this. And yeah, for the overall interview, I would say, like, I would rate you 10 out of 10 for your communication skills, for your confidence skills, and for your logical skills, right?
Yeah.
All of them are really great. Your problem solving ability is great. All right. So for that, that is 10. And for the problem solving part, I'll give you 9 out of 10, right?
Yeah.
So
Thank you so
overall,
much. Yeah.
it is, yeah, so overall it is 9 out of 10, and it was a great interview session. Actually, you performed really very well. All of the things were
Yeah.
decent, and yeah, the best thing was, as I said, your problem solving skill and your communication skills are great. Like it is that if you are having a good communication skills, then the interviewer itself feels involved with you, right? So it was
Good. Yeah.
like in this session it really felt that it was more of a discussion rather than an interview. So that is a very
Good.
good thing. It makes a teamwork kind of environment. So that was very good thing
Yeah.
about the session. So yeah, that was a great session. So you did great.
Yeah.
And anything from
Yeah.
your side?
No, I just wanted to say I really had fun discussing all the answers and coming to the solution at the end. At a point, I didn't feel like I was giving an interview. It was just a very healthy discussion with my friend. It felt
Yes.
a sort of, that kind of a discussion. So I had a lot of fun and looking forward to such interviews. So, yeah, thank you so much for having me.
Yes, you're most welcome. We hope that these sessions will help you in your preparation journey, and we wish you all the best for your future endeavors.
Yeah, definitely. Yeah, thank you so much.
Thank you, Yash. All right, guys. So there was a great interview session by Yash, and as we all see, he performed really very great. And his problem solving skills, his communication skills were amazing, and that's why this interview session was looking more like a discussion. And so that's why it was like kind of involving and engaging. So I hope all of you will get something to learn. And also, uh, there's one update for you all. Just a second. All right, guys. So there's this winter interview preparation. Like, it is a self-paced course. So all of you can join this course, and there are many amazing things that you will be taught in this course. The course content is there. You can go through it, and then you can, check it out. All the amazing things that we are doing here. Like, there is this Python for data science, then data scientist. Like, we have resume tips for placement. We have building video library with React, and all by we have live mock interview sessions as well on LLD. We have expert tips. So there are amazing things that we have there with amazing personalities, with the people with for whom you can really learn something. We have highly experienced people here. So make sure you are enrolling out in this course and you are making yourself interview ready. So yeah, that's about it. And if any one of you is interested to join our session, so make sure you are filling out the form that is given there in the description of this video. And also do share out your interview experiences as well with us. We'll be very happy to deliver that. So thank you guys for joining us, and keep up the hard work, keep up practicing. Bye everyone.